kids, they fine. So, I'm drinking my Brugger's coffee. When I like to have a cup of coffee, I drink my Brugger's coffee. It's Brugger's, all right. It is. Ooh. Anyway, here's video number 3 for the day. Yay! I'm hoping to get 5 done today in one day. I know you guys are like, that's an exciting life you lead. Get up early, drink coffee, and shoot videos. Oh my God, it's so much fun. Okay, yeah. So let me show you a couple of different ways to do these problems. I forgot to tell you. I don't know if I told you or not. Oh no, there's the pens all funky up. Not working right. Let's see if I can get it. Oh, come. Oh, yeah, there. It's got a mind of its own. All right, it's not gonna work. Oh, look, I'm not even doing anything. It's just like a phantom problem. All right, we need that, and we don't need that, and we do need that. Okay, and then you guys are like learning all my tricks on how to fix problems. Let's see if this works now. Draw, erase, erase. Oh, we'll just play black instead of erase. Erase. Ah, there we go. Is it working? Go there quick. All right. Mr. Key. I don't know. It might be working. Anyway, so yesterday we talked about how to add and subtract fractions. And what we looked at were the denominators. I'm not really clicking anything, so I'm not sure why it's doing that. So in this case, we're going to do the same thing. We're going to look at the denominators and try to find the lowest common denominator. Hold on. I'll be back. Well, I thought I fixed the problem. Apparently, I did not. So let's see if this fixes itself. So our lowest common denominator here is going to be 6. So take out my eraser. Get rid of all this crap. And what I'm going to do is, like I said, I'm going to do this 2 different ways. I know some of you may know a different way to do this. Hold on, let me drink some of my Brugger's coffee. Hope I don't lose my endorsement. Anyway, of $0.00. Okay, this was free. Someone got it for me. Anyway, can't beat free coffee. So what I'm going to do is I'm going to multiply both sides by the same number. In this case, my lowest common denominator is 6. So I'm going to multiply this side by 6. And I'm going to multiply this side by 6. Now, what happens is, and maybe this will be easier to look at if I redraw it. So let me redraw it. I didn't want to do it because I was having such problems, but it looks like I'm okay. So it's k plus 4 in parentheses over 2 is equal to k plus 9 in parentheses over 3. So I want to multiply both sides by the common denominator. In this case, the common denominator would be 6 and 6. So as long as you multiply both sides by the same thing, you're okay. So now what I'm going to say, okay, wait, 2 goes into 6 3 times. And then I'll distribute the 3. So I get 3k plus 12 equals. And 3 goes into 6 twice. And distribute this, and I get 2k plus 18. Well, if I bring this 2k over, that was really disgusting. By subtracting 2k, I get k equals, I'll bring this 12 over to this side. By subtracting 12, I get k equals 6. And that's the answer. There it is right there. Now, someone that saw all this was saying, well, why in the world would you do that? Why wouldn't you? Simply just cross multiply. That's really in effect what I'm doing. 3 times k plus 4 is this, 3k plus 12. And 2 times k plus 9 is this. And then it's solved the same way. So you could cross multiply. Now, cross multiplying only works if you have one fraction equal to another fraction. As long as, once you have more, that's all, folks. Once you have more than two fractions or one fraction equal to another, it doesn't work. So I want you to get used to doing it my way, because my way works no matter what kind of a problem we're working on. So let's take a little trip back to yesterday and say, okay, what is the lowest common denominator? Remember, it's got to have all the pieces of all the denominators. Well, in this case, here's a piece and here's a piece. So my lowest common denominator is x times x minus 2. So what we're going to do is we're going to multiply each side times x minus 2. X times x minus 2. Alrighty, if we do that, this x minus 2 cancels with this x minus 2, and I'm going to distribute this x. So I get x squared plus 2x. This x cancels with this x, and then I'm going to distribute this. Equals minus 3x plus 6. Right? Negative 3 times negative 2. Well, now that I have a quadratic because they're squared, I know that I'm going to end up having to factor this thing. So I'm going to bring everything to the left side. So I get x squared plus 5x minus 6 equals 0. Now I have to factor x and x. Multiply. Burgers, coffee's delicious. Multiply by to negative 6 and add up to 5. So that's negative 1 and positive 6. But those aren't my answers. My answers are x equals 1 and x equals negative 6. So those are my two answers. Now, I have to be very, very careful, especially when you're working with fractions. And I didn't have to worry about it over here because I had constants, numbers, only plain old numbers in the denominator. But over here, what I have in the denominator is x minus 2 and x. So we have to think, okay, my two answers I got were x equals 1 and x equals negative 6. What values would make this undefined? Well, x, for this one, x cannot equal positive 2. And for this one, x cannot equal 0. These are the restrictions on the domain. These are the values that x can't equal. Oh, okay, so I came up with 1 and negative 6, so I'm okay. So my answer is choice 4, positive 1 and negative 6. But you always have to go back and look, will your answers make the fractions undefined? So let's take a look right away. On this one, x cannot equal 0. So if 0 turns out to be one of my answers, I can't do it. All right, so if I look at these two denominators, my common denominator would be 6x. 6x. So I'm going to put a 6x next to each one. Then I'm going to grab my other funky color. Not black. Let's go blue. This x cancels with this x, and that leaves me 30. This 6 cancels with this 6. Now I'm going to distribute this x. Oh, I should have put this binomial in. So x times x is x squared, and x times 13 is plus 13x. Well, it's a quadratic, so it needs to be set equal to 0 and factored. So 0 is equal to x squared plus 13x minus 30 equals 0. Well, there's only a couple of different ways to multiply to negative 30. All of them include a positive times a negative. So a positive times a negative. And you could look at this and look at this and stare at it. And you're all screaming to your heads, oh, the answer is blah, 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 blah. Mr. Krause is so slow, he doesn't even know. That's because I'm taking the time to drink some more of my Brugger's coffee. I think that wink ranked up there with one of the most awkward moments in life. Anyway, hopefully you got 15 and 2, because 15 minus 2 is 13. So my two answers are x equals negative 15. I don't know why I have negative. Negative 15 and x equals 2. There they are. And lo and behold, there's one of the answers. Negative 15. Now, having said all this, if this is a multiple choice question, I'm thinking, let me bring this up here. I'm thinking, well, could I just go? Could I just stow negative 15? Now, in this case, you don't want to stay in a random variable. What am I doing? Negative 15, stow x, enter. And then do control division 5 over x. And it'll give you negative 1/3. And then on the other side, control division x plus 13 over 6. And negative 1/3. Hey, there it is. So quite honestly, did I even have to do any of that math? Not really. Not really. I could have just cheated. Cheater. Cheater, cheater, pumpkin eater. Don't have any idea what that means. But, all right, so let me get rid of all this stuff because it's sort of in my way. If you want it, you can go rewind it and go back to it, but it's in my way. So, common denominator here is going to be x minus 12. So what I'm going to do, wait a second, I got a binomial here. I'm going to put an x minus 12 right here, and an x minus 12 here. So this is a sort of a pain in the neck problem. Let's see what we got here. This x cancels with this x. So what I have here is I have a binomial times a binomial. Let's take a look at that. X minus 12 times x plus 1 is equal to, these just cancel, negative 7x. So the right side's pretty easy, but the left side's sort of a pain in the neck. So let's double distribute that, and I'm going to do this in my head. X squared minus 12 and plus 1 is negative 11x. Minus 12 equals negative 7x. Going to bring that negative 7x over by adding it, so I get x squared minus 4x minus 12 equals 0, right? I added 7x. All right, factoring's not too difficult here. I get x minus 6, x plus 2. So my two answers are x equals 6 and x equals negative 2. Neither of those would make my denominators undefined. The two numbers that x can't be, or in mathematical terms, the restrictions on the domain are x cannot equal 0 and x cannot equal positive 12. Since neither of these are those, these are those, knees and toes, head and shoulders, knees and toes, eyes and ears, and man, what a wonderful song that was back in like 3rd grade. All right, back to high school. So here's what we're talking about. All right, Brugger's, it was free. One of my rockin' students got me a gift card to Dunkin' Donuts. Why Dunkin' Donuts? Because it's on my way to work. And they were nice. So what we're going to do, now we have 3 fractions, otherwise known as, holy crap, I got 3 fractions. It's not a bad problem. Let's take a look. So if I look at the numbers 4 and 12, they both go into 12. They both divide evenly into 12. And I have an x, so my lowest common denominator is 12x. Okay, put a 12x next to every single fraction. 12x, 12x, 12x. Now, the reason I do this, first of all, I can multiply the left side by 12x and the right side by 12x. Now, some of you are saying, but you're multiplying the left side twice by 12x, Mr. Krause. That's not right. No, you'd be wrong, but let me show you what I'm really doing. I'm really multiplying this by 12x, and I'm multiplying this by 12x. But if I multiply the left side by 12x, don't I have to, oh, you guessed it, distribute? So really what I'm doing is I'm sort of skipping that first step by telling you, I want you to multiply everything by 12x. You're really distributing on the left side. All right, so let's go through and see what happens. This 12 cancels with this 12. That leaves me just x. This x cancels with this x. That leaves me with just plus 12. And this 4 divides into 12 3 times, so this leaves me 3x. Now, isn't that awesome? No more effing fractions. By effing, I mean fun, favoritism, and fun, more fun fractions. All right, so let's keep going. Subtract x, I get 12 equals 2x, and so x equals 6. Now again, don't forget, we got to take a look. What's the only value that x can't be? What would make this undefined? 0, of course. All right, let's go to 8. Alert! 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 We've got a negative in the middle. Alert! Alert! God, that's so annoying. Do you know why it's annoying? Mostly because it's me. And because I don't want you to forget it. So if on the test I come around and go, alert, alert, loser, don't take offense. Just realize you've done something stupid. I won't do that, by the way, but I might do it on a quiz someday. This needs to go to plus, and this needs to go to minus. Be aware of that. All right, let's take a look at our denominators. We have an x in the denominator. We have an x in the denominator, and we have an x minus 1. Now, x and x minus 1 are totally different things. They're two separate things. So what we're going to multiply on this one is an x minus 1. Now, I really like you to see you write all of this out. I am normally a one that likes to skip a few steps. And when you get to trig, when you get further on in this stuff, I might ask, you could start skipping a few things. But right now, I want to see that you know what you're doing. All right, let's do a little Christmas cheer. This x cancels with this x. So I get 1 times this. Well, that's just x minus 1. Sort of boring. This x minus 1 cancels with this x minus 1, and I end up with minus 2x. This x cancels with this x, and now I got to distribute, so I get equals 2x minus 2. All right, let's clean things up. On the left side, I get negative 1 minus x, because when I put these together, I get minus x, equals 2x minus 1. I'm going to add this x over here, so I get 3x, and I'm going to add this 1 and add this 1 here. Something's scaring me. Why am I adding 1? Good. I just got scared for a second, and now I just realized what I did wrong. This should be a minus 2. So I'm really going to add 2 here. I'm going to add 2 here, and I get negative 1 plus 1 is equal to 1. Divide by 3, and I get x equals 1 over 3. Shoot, I wonder what I did wrong. What would Krauss do? WWKD. What would Krauss would check this first before going back and erasing all of his work and verifying that indeed, in fact, I might have gotten it wrong or might have gotten it right. He would check his work. That's what I'm going to do. 1 divided by 3 stow x. Now, notice I put it in without the fraction symbol, but it turned it into something nice for me. Okay, things are going okay. 1 over x minus, so 1, oops, escape. 1, control division, 1 over x. Now, I'm going to type it in exactly as it was originally. So let me take a look at this. what this looked like originally here. So minus 2 over, so minus control division, 2 over x minus 1. And I'm going to press enter, and I get 6. And then on the other side, it's just 2 over x, so control division 2 over x. 6. Yes, kids, you're in high school now. Fractions are your friends. You know, friends. If you've never seen the movie Better Off Dead, rent it. Hilarious. And you'll know what I'm talking about when I say friends. You know, friends. It's a good movie. Common denominator between 2x, 6x, and 3. Let's take care of the number first. The lowest number that 6, 2, and 3 go into is 6. And an x is part of the common denominator. So I'm going to put a 6x next to every one of these. Wait a second, Mr. Krause. You have a binomial there. Put it in parentheses, loser. Brugger's coffee. Awkward moment number 2. Oh, wait. Now that's 3 because I did that. Now it's 4. I'm going to stop. So let's see what we can cancel. 3 goes into 6 twice. Now be careful. I have a 2x here times a 2x. So that would be 4x squared. This 6 cancels with this 6. And this x squared cancels, or this x cancels with this x. So that leaves me 3x squared minus 5 because everything cancels. 2 cancels and goes into 6 3 times. This x cancels with this x. So that leaves me plus 21. If I bring, well, this is a quadratic, so I'm going to bring everything to the left side. So when I subtract 3x squared, I get just x squared. I'm subtracting 3x squared here. And this is really a positive 16. So when I bring it to the other side, it will actually be a negative 16. Wait a second. I got to factor that. X plus 4, x minus 4. So that means my two answers are x equals negative 4 and x equals positive 4. But I got to go back and I got to take a look. What would Krause do? Krause would take a look and say, oh, the only restriction on the domain is what would make these 0. And the only thing that would make those 0 would be 0. Yay! How many more we got of these? Holy crap. I'm never getting through all these in class. It's a good thing you're here with me today. Let's get moving. The common denominator here is 12x. So now I can start looking at these things and start seeing I can move a little bit quicker. Binomial, put in parentheses, 12x. So 12x cancels with 12x. That's easy. 6 goes into 12 twice. And then the x's cancel, and 4 goes in there 3 times. So I'm going to distribute this 3. So I get 9 minus 3x squared plus, now this is 2x times 5, so that's 10x, equals 1. Now this is on the wrong side because this is negative, and I don't want this to negative. So everything's going to the right side. Everything's going over there. So 0's left over here, positive 3x squared, minus 10x. Now, I'm going to end up subtracting 9 here, and I'm going to subtract 9 here, and I get minus 8. Well, Mr. Krause, nothing multiplies to 8 that adds up to, I don't even know. Where did that voice come from? That's a weird voice. Guys, be confident in yourself. Yes, this is harder factoring because this is not a 1. When that is a not a 1, when that is a not a 1, that's good English, then you have harder factoring. The easiest way to multiply to 8 is 4 and 2. If I put the 4 here and the 2 here, I get 6 and 4, but they have to add up, so they would both have to be negative. And 6 and 4 add up to negative 10. Oh, shoot. But they don't multiply to negative 8. Oh, that didn't work. It looked so promising. I was so excited when I saw that. But alas, not going to happen. Let's switch them. 4 and 2. Now, if I make this negative and this positive, maybe that's going to work. There's negative 12 and positive 2, and they add up to negative 10. Yay! So we've already established this is going to be x equals negative 2/3. All right, I'll show you one. It's the only one I'm going to show you today, and then after this, I'm not showing you anymore. You set this equal to 0. 3x plus 2 equals 0. Bring the 2 over. I get 3x equals negative 2. Divide by 3, and I get x equals negative 2 over 3. So there is, wow, one of my solutions. My big head was probably in the way. And this one gives me x equals 4. Take a look back at the original problem. What are the only values that would make the denominator undefined? Here and here would be 0. So I can keep both of those answers. Both those answers are good. So yes and yes. All right, again, common denominator here is 2x. So we're going to do 2x, 2x, and 2x. 2's cancel. I'm left with x. 2x cancels with 2x. I'm going to distribute this minus, so that's minus x plus 8. X cancels, and I get plus 2. Wow, this is an easy one. Bring this x over, I get 2x equals 10, or x equals 5. Ka-ching! That was annoying. 4x is my common denominator. Yes, I'm moving quickly. You need to pause. 4x and 4x. So 2 goes into 4 twice, so that's 2x times 1, which is just 2x. This 4x cancels with this 4x, leaves me x squared minus 7x plus 10. 2 goes into 4 twice, and the x's cancel, so plus 2. Everything needs to go to the right side, so 0 is equal to x squared minus 9x plus 12. Ah! Dummy! This should be a minus here, so this is plus 8. I was just looking at it. I knew it wasn't going to factor because I ran it through my head, and I'm like, what did I do wrong? So x minus 1, x minus 8. Multiply to positive 8, add up to negative 9. Not too difficult. X equals 1, x equals 8, and the only restrictions on the domain are x equals 0, so we're good to go. And that was probably really close to where my big fat head is, so let me just slide over, roll it up a little bit, and go, there it is, kids. Take a look. While you're taking a look at that, I'm going to take some time to drink some of my Brugger's coffee. All right. Hey, someone yelled through the computer to remind me to move my big fat head. All right, so this, oh, be careful. This is over 1, but this one isn't too bad. My common denominator here is between 2x minus 1 and 2x minus 1 and 1 is, you guessed it, 2x minus 1. 2x minus 1 here, 2x minus 1 here, and a 2x minus 1 here. Now, here, which is nice, these cancel. I'm just left with 3x squared. Here, the 2x minus 1s cancel. I'm left with positive 3x minus 4. This one, nothing cancels, and I have to distribute this negative. Be careful, it's a negative, so it's equal to negative 4x plus 2. Everything slides to the left side because this is where your squared's positive. So 3x squared plus 7x minus 6 equals 0. And yes, I know nothing multiplies to 6 that adds up to 7, which is not entirely true, but in this case it is. So 3x and x. And in order to save a little bit of time, I'm just going to tell you. First of all, the easiest way to multiply to 6 is 3 times 2. I can't put the 3 here. So I'm going to put the 2 here and the 3 here. They have to multiply to negative 6 and add up to positive 7. So this one has to be positive and this one's negative. So just like I said, I'm not going to show you the steps, but this one, set that equal to 0 and solve. You get x equals 2/3 and x equals negative 3. Well, I should have taken a look. Sorry about that. I should have taken a look at the original problem and see what makes the denominator equal to 0. Well, what would make this equal to 0? If I set that equal to 0, I would get x equals 1/2. So my restriction on the domain is x can't equal 1/2. Since neither of those is 1/2, I'm okay. 14 is very difficult, so let me come back to it if I have at the end, and let's see if any of these are easier. Okay, so what I'm going to do is I'm going to do 15 first, then I'll go back and do 14. 14 is really a pain in the neck. So let's take a look. 15, put this over 1. So my common denominator here is just x minus 3. So I put an x minus 3 here, an x minus 3 here, and an x minus 3 here. This one's actually very easy. These x minus 3's cancel. I'm left with 4x. Nothing cancels here, so distribute. So I get equals 2x minus 6. And then these cancel, and I get plus 12. Bring the 2x over. I get 2x equals, that should be 12, 6, or x equals 3. But we got to look to see what would make our denominators undefined, because we got to see if we got any problems. And what would make this equal to 0? Well, if x was equal to 3, so x can't equal 3. That's the restriction on my domain. Oh, wait a second. 3 was the only answer I came up with. So the answer to this question is, you guessed it, empty set. No solution whatsoever to this problem. Can't be done. All right. So let me tell you and explain to you why this one is difficult. So this is okay. This one needs to be factored to x plus 5. X minus, what did I just heard alert, alert, alert. Captain, we have a negative in the middle. Let's get rid of that. Yeah, that's the problem. We're going to get rid of this negative and make this a minus and put this in parentheses. Now, let's investigate this. 5 minus x. Raise your hand if that looks weird. By the way, if you're raising your hand right now, look in the mirror. That's the weird thing, because you just raised your hand to a computer. You know I can't see you, right? Because that would be extremely creepy. I'm just talking into a camera. It may look like I'm actually talking to you right there. No, yeah, you. Raise your hand. Got you again, sucker. Anyway, does this look weird to you? It looks completely backwards. Like it would look normal if it would look like this, right? X minus 5. And I know you guys like, oh, they're the same thing. They're not the same thing. Do you remember when we had something backwards and something normal yesterday or 2 days ago and they divided, and what do they divide to make? Do you remember what they made? Do you remember what was the -1 rule? This is a kind of a this came out of the -1 rule. This is an extension of the -1 rule. This is a little bit more with that -1 rule. If you have something that looks backwards and you really want it to look normal, it's still the -1 rule. You just got to put a negative out front. Now, let's see what that really does. If I distribute this negative here, what do I get? I get negative x. And if I distribute that negative here to -5, I get positive 5. Well, positive 5, there's a positive 5. Negative x, there's a negative x. So, here's what I'm telling you. If you ever see something that looks backwards like this, you can turn it around. So let's do this in black. I'm going to turn this around. I'm going to make this x minus 5. But in doing so, I have to put a negative out front. Now, here's why this problem's even more tricky. Don't I have a negative in the numerator and a negative in the denominator? Well, don't those cancel each other out and make a positive? So I really end up with a positive. Oh. So let's see what I got here. I end up with 2x over x plus 5 plus 1 over x minus 5. Remember, there was a negative up here, and I did switch it around by putting a negative, but these two negatives really made a positive. Equals 10 over x plus 5, x minus 5. All right, now that I've looked at it like that, now I could say, okay, the common denominator is x plus 5, x minus 5. So I'm going to put that next to each one. X plus 5. And you know what? This is kind of annoying, but so are you. Just kidding. I really like you guys. Put it next to each one. X plus 5, x minus 5. X plus 5, x minus 5. All right, now let's look to see what cancels. This x plus 5 cancels with this x plus 5. So here's what I have left. But I have to distribute the 2x. So I end up with 2x squared minus 10x. The x minus 5s cancel. And I have to distribute a 1, but that's kind of easy. That's just plus x plus 5. Everything cancels here, which is really nice. So I'm just left with equals 10. I do have a squared, so everything must come to the left side. So I'm going to put, so let's say 2x squared minus 9x minus 5 equals 0. All right. Now we got some factoring to do. 2x and x and minus 5 and plus 1. This makes negative 10, and this makes plus 1, and that adds up to 9. So my two answers are x equals negative 1/2 and x equals 5. Now here's the wonderful thing. You get so excited. I got to the end. It was factorable. It must be right. Brugger's coffee. You must go back to the original problem and look. What are the restrictions on the domain? What would make this 0? Oh, negative 5. What would make this 0? Oh, positive 5. And of course, over here, plus or minus 5 would make this 0. So x cannot equal plus or minus 5. Those are the restrictions on the domain. So you always have to go back and look. Oh, look, this answer doesn't work. Even though it's an answer, it doesn't work. All right, here we go. Alert, alert, alert. We have a minus. Let's get rid of it. I don't care. It's going to be the first thing we do is always get rid of that minus. This is x plus 3. Backwards, backwards. Alert number 2, it's backwards. So we're going to switch it around. X minus 3, but put a negative out front. And yes, you are right. These two negatives will make a positive. So I might as well do it right now. And here my common denominator is x plus 3, or my factor denominator is x plus 3, x minus 3. So let's see what I got. I got 1 over x plus 3 plus 2 over x minus 3 equals 4 over x plus 3, x minus 3. And someone already said, I think it was the guy over there. Yeah, you, the weird one. The other weird looking one. No, the one with no hair. Yeah, you. Jeez. Was saying the restrictions on the domain, Mr. Krause, are x equals plus or minus 3. So if I end up with one of those answers, I better cross it off. So anything with a 3 as a number needs to get crossed off. So my common denominator here is x plus 3, x minus 3. X plus 3, x minus 3. X plus 3, x minus 3. And yeah, that takes about 30 seconds to write. Don't be lazy. All right, the x plus 3's cancel. I'm left with x minus 3 plus the x minus 3's cancel. I'm left with I don't know what this is here for. I'm left with the x minus 3's cancel. I'm left with 2x plus 6. Everything cancels here, so I'm left with equals 4. All right, on the left side, I get 3x plus 3 equals 4. So I get 3x equals 1, or x equals 1/3. Now, 1/3 is not 3, but it is a little weird. I don't know. Let me check that answer. I'm going to do my last little check here. Now, the cool thing is I already have 1/3 stored into x, so that's good. So let me go back here. Don't need you. And see what my original problem is. So my original problem was, I really need to see this. Again, we're not changing anything. So 1 over x plus 3. Control division. 1 over x plus 3. Now the only reason I can do this is because I still have 1/3. If you look. I still have 1/3 stored in x. Minus 2 over 3 minus x. 2 over 3 minus x. And hit enter. Well, that's a weird answer. So then I've got control division. 4 over x squared minus 9. I got the same weird answer as I did before. Negative 9 over 20. So yes, in fact, we have the correct answer. It is 1/3. Well, that's it, kids. Yay! Day 5 is over. That's a 5. And my awkward winks are over. And my strange cup of Brugger's coffee is being downed as we speak. It was fun sharing the last 41 minutes with you, kids. I enjoy every minute I can spend with you. I'm like your little buddy in the corner. We're pals. So if we're pals, hit the subscribe button. If any of the commercials that popped up fancy your interest, click on those too. Maybe you'll find something that you'd like to buy me. The only thing I need is a computer. Everything else I have. All right, kids. It's been fun. It's been real. But you know, it hasn't been real fun. Bye.